make sure that it actually makes sense. All right, so I need A, B, and C. I could actually do this, right? Not A. What else I need? Any other complements I need? No. So I will just do that one, calculate this easily, calculate that easily. Let's call this 1 and 2, all right, and 1 plus 2 here, okay, because that's the function actually, this is the function. And also this guy right here, I need B plus A, and finally I need, this is 3C, all right, so how many? Okay, I need 8. I don't think I'm gonna fit in here. 1, 2, 3, 4, 5, 6, 7. You know what? We should just do half of it. So with 3 items, I need 8 values. So 0, 0, 0, 0, 1, 1. Let's keep it that way. We're gonna, if the output is similar for the first 6 items, we will just assume that it's okay. I don't want to throw down here. So 0, 0, 1, 1, 0, 0, 0, 1, 0, 1, 0, 1. Not A is 1, 1, 1, 1, and 0, 0. Not A, B, C. So I'll just do this row. 0, 0, 1. This is an AND, not an OR, so this is an AND, means that 0, 0, and 0, and 1, and 0, and 0. All right. How about AC? A and C, 0, and C. Okay, 0, 0, 0, and 0, and 1, just here. And then 1 and 2. Now we're gonna do the OR, right? So this is gonna be 1 and 1 here, and then 0, 0 here. And A or B, that means I have only 2 zeros here, and then the rest is gonna be 1 because at least 1, 1 on either variables. And 3 times C, meaning that and C. It's an AND operation, by the way, so 0, 0 is 0, 1, 0 is 0, 0, 1 is 0, and 1, 1 is 1, and 0, 1 is a 0, 1, 1 is a 1. So what I want to see is 1 plus 2.
Where did that value come from, Professor? Where'd you get that 1 plus 2? What is it?
It's number 1 here.
Oh.
This guy,
Okay. Sorry.
or
Sorry.
this guy.
Gotcha.
Can I ask you one thing?
Alright, so let me finish this one. Is it the same thing, 0, 0, 0, 0, and then 1 up, and then 1. So it is the same thing, right? So the point was actually I was trying to make here, this can be expanded as only B plus A because of complements involved in here. So that was a shortcut in the textbook, one of the rules, I guess. So it looks like it's impossible to figure this out, but if you use that rule, you can figure this out very quickly. But suppose that you don't remember that rule, you didn't remember it, but you have to find the reduced version. What is the other option you have? You know it. I mean, it's almost, you may not know it because you were not in the class.
That's formula.
Yeah.
We can use this formula.
What, this?
So CB
Plus the AC?
plus A.
No, no,
plus
no.
CA.
From here to here, how can you go? I'll give you the answer. Don't kill yourself. All I need is the truth table of this thing, all right? Meaning this, zeros and ones, and then K-map. Remember that?
How do you got that 1 in BC? Oh, that's BC.
3 is a B plus A.
Oh,
I thought it was BC, but actually it's 3C. Never mind.
oh yeah, it's 3C. Yeah. I mean, B plus A is 3, actually. C C3. I'm just, I don't have enough space, that's why I just put one.
Let me ask you one question.
Yes.
So multiply is or and plus is an and
The opposite.
the opposite. So
Right.
multiply is
AB is A or B. Oh my God, look what you had done. A plus B is A or B. Well, in many textbooks, this is A, this symbol, and B, that is A, this symbol, and B, and not A. In many textbooks, it's like this, not A. In some of them, it's like this, not A. In some of them, it's like this, not A. It's like, you know, meters or inches, whatever. I mean, but in our textbook, we're using this version, and that's these two. Okay, so there's a nice example that I want to show you quickly. Okay, you're done with that. Let me show you this one.
I'm sorry, what was the K-map?
Is the key map based on the F output?
The K-map is always about F. Nothing about input or in between calculations. It's always about the final output. All right? We will do a lot of K-maps today, so don't worry about it. Yes?
When, it's like probably a really stupid question, but so in the example that you just did, I got to the same like simplification. I just did the complement and then I got it, but I could have stopped one step right before I got it, and like you arguably so it could be like, I don't know, considered like as simple. So my question is just like, when do you know how to stop? For instance, like this. Yeah, I mean, it's the same as this, just like, how do I know, why don't I just stop here? Why do I go all the way?
Because you cannot, well, yes, that's a good question.
It's three terms of one, or
Right.
it seems just as simple, so how do you know when to stop?
It looks like simple enough. Why would I go further? That's the question, right? That's a really good question. In two situations, you may want to go further. Number one is the school playing. We give you the function and we give you the possible outputs, the answers A, B, C, D. Which one is gonna be the answer? And your answer is not gonna be in the list, and you will be confused. Oh my God, why is it not in here? This is simple enough. So you will know that then you should go further. The second one is even though it looks simple enough, if it requires more gates, then you really want to go deeper. But this Boolean algebra method, manual method, we don't really use it. I mean, we just want to know there is something that exists, but what we do is, we use computers for everything, but what we do in general, we use the K-map thing. All right? I'll show you a very simple K-map, a couple more examples, and one or two advanced ones, and it will be a really nice one. But before I do that, I want to show you something, a nice example. B not C plus not AD, okay, and A not B or C not D. What do you think about this one? Okay, I'll give you 2-3 minutes for you to work on it and then see if you can come up with an answer. And I will actually give you an A for that. What about don't forget to sign in, by the way, on the attendance sheet, please.
You can remove B's, right?
You're an extrovert, aren't you?
What's that?
You can remember what?
B's. Because
How can you do that?
complementary.
I don't know.
You can remove B's.
The complement rule was actually applied only if three variables involved in one, not A plus BA. In this case, what was that? I already forgot about that. I think it was like this. How was it? Well, let me check. Oh, yes. Not A, B plus A, actually this one is becoming only B plus A. We can just get rid of this A, not A, I mean the complement. But in your logic, you say I can get rid of B's because I have complement in here and there. That doesn't apply to this one. Anyone has a solution so far? Yes.
Yeah.
0.
Yeah.
Okay, how did you find it?
With fraction, which B.
You did this?
Yeah.
Oh, okay, let's do it. All right, get your A. There was another 0 I heard. There you go. Nah, come on. Come on. Nice
The
try.
first part is a B and B.
Look,
It's 0.
what do you see here?
B
This
and
is an AND operation. In an AND operation, if I have at least 1 0, it just destroys everything, deletes everything, right? Suppose that B's value is 0 and not B is gonna be 1. If it is 1, it's gonna be 0. That means in any case, I'm gonna have a 0 here. So that is out. How about the other one? B, not C, C, not D. Same thing. I got complement and itself in the same thing. It goes away. And the next one, not A, D, A, not B. Same thing, A, not A, in an AND operation gives me 0. And then the last one, not A, D, C, not D. I got D and not D. That goes away. It's a simple 0 at the end.
Wait. Oh, yeah.
Okay, remember, this is an AND, or, and, or, and, or. I'm sorry, or, and. That's not all, just the XOR. Jesus. All right, anyways. So there's another example actually similar. It gives you the result it gives you is weird. It's just 1, but it's not in here. It's okay. All right, the other thing, complements. You're gonna have just one question probably about that complement. What's a complement of a function? Oh, it's here. You're just gonna follow 2 basic rules, regardless of the function itself. X or Y complement is not X and not Y. All right. Just we can actually check it like this. And we have all right, 0, 1 is gonna be a 1 and then reverted into 0, right? And 0, 1, this is 1 here, and this is 0 here, 0, I'm sorry. And let's go for a 1, 1. 1, 1 is gonna be a 1, converted to 0, 1, 1, 0, 0, and that's a 0. Again, it's a 0. Anyways, it does actually check out. And the other one is X and Y complement is X, not X, or not Y. This is the only thing, formulation that you need to remember during the examination. And this is not like this, by the way. Don't get confused with this and that. They are not equal. As you see, there's a parenthesis covering two variables, not just one. All right. So one example. I'll give you one function, and then you will calculate different outputs, different combinations of that function. You know. All right. I just put everything. I'm very organized. Look at that. All my stuff is here. So function is not xy plus xy not z. This is the function. I want you to find not f and f not f and f not f or not f. We're going to just apply the rule here, right? So you're going to start with not f, meaning that x not y plus xy not z complemented, and that means every single item will be inverted, right? So not xy, not, that or becomes an and xy not z not, right? So that will actually expand one more time. So it's going to be x plus not y, right? And then that will be not x plus not y plus z, all right? And then you will go further, x not x plus x not y plus xz plus y not x plus not y plus not yz. And you already know that 1 and 0 is a 0, that goes away, and not y and
1,
and not y,
1.
how's that?
Yeah, it's true.
If y is 0, not y is 1, not y is 1. If y is 1, not y is 0, 0, 0 is 0. So, difference. So, your conclusion is not right. Not y is not 1. Not y actually, just 1, not y. It's not 1, right? Okay, just show you. That is a one single not y. If you go further, obviously you're going to need to go further. Okay. What do I have? I can actually look for these similar variables. I got x and x here. And I got y, not y, and not y here.
Z's.
And z's, okay, I have, but I want to use this one here, so I cannot really do that. X, parenthesis, not y, plus z, okay, plus not y, parenthesis, not x plus 1 plus z. Well, actually, yeah, that works, right? So what do you think about this piece here? X or 1 or z. Actually, I can add a lot of stuff into it. It doesn't matter because this just 1 will make everything else 1, right? So that is actually a 1. Okay, so that means x, not y, z, and not y. Well, actually, you can actually get rid of this thing. Oh, you can't. All right. So, okay. And and then x not y plus xz plus not y. One more step actually, not y, x plus 1 plus xz. That is also going away. X plus 1 is always 1 regardless of x's value. So the final product is not y plus xz. That is your not f. Okay. You should do it yourself on your paper to see how it works, because watching is not always
Professor, if you,
just enough.
would you mind just writing out what f times f naught would be?
This
lost-
one?
Yeah, I lost it in the steps somehow, sorry.
I didn't do that yet. I just did this one. This is not f.
Oh,
This
okay,
whole thing
sorry.
is just not f.
That makes sense, sorry.
Right. But you don't have to kill yourself for the rest. Why? Because function and its complement is like a, not a. What is this? This is an AND operation, right? 0 and 1, 1 and 0. It is always 0, right? So here. And for the function is again the same thing. This is an OR operation, and 0 or 1 or 0 is the same. It's always 1. I mean, it's again, it acts like a variable, the whole thing, whole piece, whole function, because you're taking the complement. If you follow the rules, you got the correct complement, and if you do that, let's see. Actually, you really want to. Okay, I really want to see that. Just one of them, all right? Just one of them. I want to see if that is the case, all right? So I want to do this. I want to see if f and not f is 0 or not. I want to make sure, right? So let's do that. X not xy plus xy not z times my complement not y plus xz. What is the output? I'm expecting as 0, right? So if you do that, right, plus not xy, xz plus, now you're gonna do that, and xyz, not z, not y, plus xy, not z, x, what? Wait, what?
XZ.
xz, right?
Mhm.
It looks weird.
That's right.
Anyway, so what is this? If you end a variable with its opposite, it is always 0. We know that already. And I have these two here, and that here, and that here. So everything is 0. Everything. So that is actually correct. You could use multiple other ways to prove that the output is actually 0. You can use the K-map or whatever. You can draw the gate, etc. It will always work, right? So this is a sample actually. It might be a nice sample. I will just give you a function and then ask you what is the complement, what is the output, and then maybe I will trick you with this. 2 not f plus f. What's the output? 2 not f plus f. What is the output? Yes. 1?
F.
How? Okay. How about now? 2 not f. What is it? What's the output?
Is it not F and not F?
I don't know. What do you think? Yeah, that's the actual question. 2 not f, or okay, maybe not f is confusing you. What is 2f? It doesn't mean anything. You can't do this. I mean, this operator is not defined in Boolean logic. This is not 2 and f. There is no such thing. We only have 0, 1s, and those and or x or whatever, right? There's no such operator like multiplication in Boolean algebra, right? No such thing. So undefined. The answer is undefined. There's nothing such thing. It's not gonna work like that. But you might think that, oh, you know what, 2f actually means f plus f, right? You might think that way, but no, not like that. It's not the same thing. Anyways, now we're gonna have fun. Okay, I can get things in order. All right, K-maps. We're actually approaching, okay, it's actually the first half. Oh my God. I didn't think that, it was gonna, is it recording? Do you see anything on?
Yes.
Okay. K-maps or Kano maps. Okay, I saw some weird ones. You should always remember that you have n variables, you have to the power n rows all the time in a truth table. That's a given, right? So I want to do this. This is the notation we have seen before. If you have that, you will have these kind of questions. I'm not going to give you the truth tables or whatever. I mean, you will get this scientific notation or formal notation or how to define a function. All right? What does that mean? I mean, if you don't know, that means this function takes two variables, a and b, and in the k-map, only number 1, the cell number 1 and 3 has value of 1. 1 and 3. What does it mean? Cell number 1, cell number 3. We know that, right? So we have this, I'm just translating this thing, okay? I have a truth table with two variables, all right? And I have the function here. Okay, so since I have two variables, 2 to 2 is 4, 1, 2, 3, and 4. Okay, so 0, 0, 0, 1, 1, 0, and 1, 1 is the default pattern that I use, all right? So when you look at these numbers, they are actually matching with the decimal values. We talked about that before. This is a 0, this is a 1, this is a 2, and this is a 3. So that means only row number 1 or cell number 1 or cell number 3 has a 1 value. The rest is by default 0. There comes my truth table. Well, I don't really need to do that, but just to give you the idea, this translation actually makes sense, right? And that notation is actually derived from the truth table. So what do I do with how do I generate a k-map? And what is the purpose of a k-map, by the way? Why do we do that?
The function, the original. To get the function?
To what?
To get the function?
We have the function already.
To get the circuit,
To get the circuit.
you get the.
Exactly. I mean, you meant that probably, but silly me, couldn't get it. Yes, to get the function expression. The only reason we use k-maps to produce the most reduced or simplified version of a function expression. Well, actually, this is a Boolean expression, right? We're talking about Boolean stuff. Anyways, once I got the truth table or got this formal notation of a function, now I can work on it. All right? So I have two variables meaning 4 boxes. 2 is 4 boxes. I'm sorry. Yeah, 4 boxes, 4 cells. So 1, 2, 3, 4, like that. So I have an A, I have a B. And every box is actually corresponding to a row. For box 0, I need 0 and 0. So I put values here, 0, 1, 0, 1. This is the coordinate for 0, 0. Actually, it is the input for 0, 0, right? What is the value of the function? It's a 0 right here. So you always read in order, A, B, right? So this is gonna be 0, uh-oh. You see that? I made the mistake myself right after telling you. That is for the row where A is 1 and B is 0. A is 1 and B is 0 is row number 2.
Shouldn't A be on the bottom and B on the top?
Doesn't matter.
Doesn't matter?
Well, actually, it does matter, but you know, the view will be different, but when you work on it, the output will be the same. You can have different ones on different places if you change the order, but the after working on the the grouping and other stuff, the result, the expression you get is gonna be the same. All right. So right. 1 and 0 is 2 here, and 0 and 1 is 1 here, and then 1 and 1 is 3 here. Okay, so these are the coordinates 0, 1, and 1, 1. Okay, 0, 1 is 1, and 1, 1 is 3. Okay, what if by the way, I just put the numbers here, but I really need to put the values. So I'm gonna get rid of these now and put the actual values. For 1, I need a 1. 1 is 0, 1. I need a 1 right here. And I need a 1 for the 3 value, which is right here. The rest is 0. Okay.